Okay, good afternoon. We're going to continue talking law of sines today. Yesterday I gave you the introduction to law of sines, the basic formula, and also we did some basic examples. And the idea again was that anytime we know a pair, which once again meant we know a angle and a side opposite. As long as we know one pair within a triangle, then we can apply law of sines. So the catchphrase with law of sines is that we have to know a pair, right? We need to know an angle and a side opposite for law of sines to work. So in this one that I just have drawn out here, we know angle A, and we know side A. We know this pair, and therefore when we set up the proportions, we know both the top and the bottom of one of the fractions, and therefore that allows us to cover up one of the other fractions at a time and cross multiply to find missing pieces. Okay, and that's all fine, that works great, but the problems we focused on yesterday dealt with triangle situations where you were given a picture, so therefore you knew exactly what was going on. There's a more difficult problem that we need to start talking about today, and it's a type of problem where we're not given a picture, we're only given information about a picture. And the information that we're going to be given in these types of problems, so the information we're going to be given is we're going to be given two sides and one angle. Two sides and one angle. So the abbreviation we learned in geometry last year, SSA, right? Two sides and an angle. But here's the key, no picture of what's happening, okay? All right, so that's the type of problem we're gonna be talking about today. It's a tough one. So we have to really work through, talk through some different kind of scenarios as to what can happen. And because it's difficult, we're gonna break this into two parts. We're going to break it into two parts where the given angle is first obtuse, and then a second scenario where the given angle is acute. Okay? When the given angle is obtuse, there's going to be two possible situations, and when the given angle is acute, there's going to be three possible situations. Okay, so overall, we're going to end up with 5 scenarios where we have two sides and an angle given, but again, here's the important part, no picture, no graph, nothing visual as to what's going on. We have to determine the visual ourselves. And so this is one of the more difficult ideas we talk about here in pre-calc. And this idea that we don't really know what's going on because we're not given the picture leads to the name of this type of problem, which is called ambiguous. Okay, so we're looking at an ambiguous triangle situations, and I'm sure you all know the word ambiguous just means open to more than one interpretation. Okay, so how does this play out? Well, we're going to start with the one that has fewer options. We're going to start with the situation where we have an obtuse angle given. Okay, so we're going to be given two sides and an angle. So let's start with obtuse. This is going to be the situation we're in to start with. Okay, and so of course an obtuse angle means an angle bigger than 90 degrees. All right, and again the situation we're going to be given is two sides and an angle. Okay, please notice that the angle is not included between the two S's. So again, from geometry class last year, that means the angle is not included. So if I just remind you of that, angle is not included, right? That was the geometry word that we used last year. In other words, the angle is not in between the two sides that we know something about. Okay, so here's the two scenarios that we can have with an obtuse angle. So if I have an angle located here at A, point A, and the angle is obtuse, okay, greater than 90 degrees. Now, because the angle is not included, one of the sides that makes up the angle is going to be unknown to us. One of the sides that makes up the angle is unknown to us, so I'm going to make that a generic length that we don't know anything about to start. The other side we are going to know something about, and I'm going to choose to call that little b. So I'm going to say little b is that side. Of course, that can't be little a, because little a has to be across from angle A. So I'm going to make side B that long, okay? Now, since side A has to be directly across from angle A, that makes this unknown side, down here on the bottom, what you guys might think of as the base, that makes this unknown side, side C. Oops, that's a terrible brace, holy Moses. All right, so that makes this unknown side down at the bottom C. Okay, so that's kind of the situation, right? And so I've kind of set up angle A, it's obtuse. I've set up one of the sides. We've just kind of made it a generic length, B. And now the other side that we have to fill in, therefore, has to be side A, because again, the angle is not included between the sides, okay? And we have two choices. We have two choices for A. So when I sketch in A, okay, and what I'm going to do is I'm going to purposely make side A such that at this point, which would be, of course, angle C, all right, we're going to pretend that side A can hinge or pivot on this point, okay? So back to, let's pick a different color. So however long side A is, we're going to pretend that we can swing this arm of the triangle up and down. So we're pivoting. We're going to pivot about this point right here. We're going to let that be a hinge or a pivot, okay? Now we have two choices for that situation. Okay, let me draw in the side A on the second triangle. So this is the A. Once again, we're going to pretend that A can hinge or pivot on angle C. Okay, so once again, let me, in red here, we can pivot this point up or down. Okay, we can swing that arm. We're locked in at A because we're given that angle. Okay, but the other angles we don't know anything about yet because we weren't given a picture. Okay, and we have two choices here, two things that can occur. We have two things that can occur. If A is shorter than B, if A is shorter than B, no matter where you swing A, of course, if you swing it up, it makes no sense because you can't create a triangle. But if you swing it down, because A is shorter than B, because A is shorter than B, A never hits or intersects side C. Because A is shorter than B, A never intersects side C. And in that situation, we're going to say then that there's no triangle possible. And therefore, if I asked you guys to find the missing pieces, you would say, I can't because there's no possible triangle. But if A is bigger than B, if A is longer than B, then when we swing that arm, remember we're pivoting A on that, on point C. Again, it doesn't make sense to swing it up because I can't create a triangle. But when I swing it down, it is going to intersect side C. And because it intersects side C, then I know that A is really going to fall right there, and now I can complete my triangle. This would be side C. And we'd be able to actually create a triangle. So what we say then is if A is greater than B, then we have one triangle possible. And what we're going to ask of you is to solve for the missing pieces, just as we were doing yesterday. Just like we did yesterday. Okay? Alrighty. So that's the idea with an obtuse angle. With an obtuse angle. Okay? So now what I'd like to do is 2 numerical problems with obtuse angles. All right, we'll start with the easy one. Okay, so here's an easy one. Here's the given information. Angle A is equal to 110 degrees. Side A is 14 units long, and side B is 18 units long. No picture, right? So the directions are going to be simple. If possible, find the missing pieces. Okay, so you have to first figure out, can I draw a doggone triangle in the first place? So what we do is we start with the angle A, right? Now, because that's angle A, therefore angle A is going to be made up of side B and side C. We're not given any information about what side C is, so initially we just make side C an indeterminate length. We don't know how long the darn thing is. The other side that makes up angle A is side B. And side B is 18 units long, so we draw it so that our angle would be 110 degrees. Okay, and we draw side B so that it's 18 units long. Okay? Next, we consider what would happen when we try to draw side A. All right, side A is 14 units long. Once again, we're going to pretend that that side can pivot at angle C. Right, so let's put in C at that point. Okay, and we're once again going to pretend that it's going to pivot, swing at that point. So it could swing up, which of course doesn't make any sense because we can't create a triangle swinging it up. But when we swing it down, is the 14 unit side going to be able to get to side C when B is 18 long? No, because when we swing it around, because A is shorter, no matter where you swing it to, it's not long enough because it's shorter than B. It's not long enough to get to side C. So no matter where you swing it, it can never hit side C. And therefore, we would say that there's no triangle possible. Therefore, no solving to do. No solving to do. Okay? The second example, obviously, is going to be one that we can solve. So here's some information for a second one. Again, no picture. So angle A is 110 degrees. Side A is 14 units long. And side B is 8 units long. Same setup. We start with angle A. Angle A must be made up of sides B and C. We know nothing about C, so we make it an indeterminate length. Side B is 8 units long. So we draw in a side that is 8 units long. And the angle at A again is 110 degrees. This time our other side, A, is 14 units long. So we know that A, I'm going to draw it almost horizontally just so you can get the feel for it. So A is then going to be 14 units long. And once again, when I swinging it up doesn't make any sense, but when I swing it down, it is then going to hit side C. And therefore, now we can complete our triangle using 14 for side A, 8 for side B, and 110 for angle A. So that makes this then side C, this one angle C, and because we know a pair, we know an angle and a side directly across, we can use law of sines to find the missing pieces. Okay, so we set up our 3 equal fractions using sides, side A, side B, side C, and we use the sine of each angle across. Okay, 14 is across from 110 degrees, 8 is across from angle B, and side C is across from angle C. So very, well, almost identical to the ones we were doing yesterday. We cover one fraction up at a time. And so the one I'm going to pretend to cover up, I'm just going to choose a highlighter. I'm going to pretend to cover up the third fraction and cross multiply with the other two. So I'm going to cross multiply with these two. And so go in one direction and have 14 times the sine of B, and go in the other direction and have 8 times the sine of 110. So to get rid of times 14, divide by 14. So I'd have 8 times the sine of 110 divided by 14. And then to get rid of the sine on the left, I do the inverse. So I take the inverse sine of both sides. And whatever you do on one side, do on the other. So I'd have the inverse sine of 8 times the sine of 110 divided by 14. On the left-hand side, inverse sine and sine cancel, leaving us with angle B. And on the right-hand side is your calculator problem. So we have the inverse sine of 8 times the sine of 110 divided by 14. And we get an angle of 32.5 degrees. Okay? Now that I know angle B is 32.5, and I was given that angle A was 110, I can then just do the old subtraction method to get to angle C. Okay, so therefore start at 180 degrees, subtract away the 110 for angle A, subtract away the 32.5 for angle B, and whatever's left over is going to be angle C. So let me subtract for everybody. 180 minus 110 minus 32.5, and what we get is 37.5. So there's our second missing piece. And not only is that a missing piece, but it allows us to then go back to our proportion and replace angle C with what it's equal to. So I could then scratch out angle C and replace it with 37.5, which then allows me to cross multiply with two other fractions, just as an example. How about the first and the third? So if I cross multiply this way, I'd have C times the sine of 110, and cross multiply this way, I'd have 14 times the sine of 37.5. Then to get little c by itself, I just divide both sides by the sine of 110, so that those cancel, and little c, the third part, the third missing part of our triangle then would be 14 times the sine of 37.5 divided by the sine of 110. And if I punched OK, I got 9.07. Let's just call it 9.1. So let me shrink the screen down so you can see everything at once. Okay, and we'd have all three of our missing pieces. Again, we can always solve anytime we know at least half of the parts of a triangle and we know at least one side. Okay, as long as the triangle is possible, we're good to go. Okay, now I wanted to, since I know this is difficult stuff, I wanted to break today into two parts. What we've done so far is the ambiguous situation with an obtuse angle, and then I'm going to just create another video with the acute angle. So I'm going to pause this one so that you guys could take a look at those examples in your those problems in your assignment is what I meant to say. Okay, and then when you get the chance, start up the second video for acute angles. Okay, all right, thanks. Talk to you soon.